Bracket open, bracket close, let the function forge ignite. Welcome back, apprentices. Today, we're hammering into one of the sharpest evolutions in the modern CSS tool chest. Today, we make our style sheets think. CSS functions, var, calc, min, max, and clamp, are how we stop treating styles as static declarations and start treating them as systems. Systems that scale, systems that adapt, systems that prevent their own breakage. If CSS variables turned our design tokens into reusable building blocks, CSS functions turn those tokens into logic. Values become calculated, bounded, and responsive, without media queries, without duplication, and without layout hacks. That is what we're forging today. CSS that behaves intelligently. Let's step into the furnace.
Hello, students. TA Watts here, booting up your next lesson from Professor Solo. Okay, let's just jump right in with a question. What if your CSS values could, think? What if they could actually calculate things, adopt on the fly, and even protect themselves from breaking?
Well, welcome to the CSS Function Forge. This is where we stop treating CSS like some static, boring list of instructions, and we start crafting values that are truly alive.
So, step right up, apprentice. The anvils are glowing. Today, we're going to transform your code from just static decoration into living, breathing arithmetic.
Check this out. On the left, you've got the old way, a static value like 320 pixels. Yeah, it's predictable, but man, is it brittle. Now, look at the right. That is a forced value using clamp. It's fluid, it's intelligent, and it's responsive just by its very nature. This one little comparison shows the huge leap in power we're about to unlock.
Static values still have their place, but the moment our UI needs to respond to anything, viewport, container size, user preferences, hard-coded numbers collapse under pressure. Clamp isn't just a flexible value produced by a function. It's the first step towards declaring intent in our styling. Minimum acceptable size, ideal responsive size, maximum permitted size. That triangle of constraints is meaning, codified directly into our CSS.
Our journey into the Forge starts with two basic actions: summoning our raw materials and then shaping them with precision. Let's get to it. First up is var. We're going to call this the rune of invocation. I want you to think of it not just as a variable, but more like a summoning spell. You call its name and poof, it brings a stored value right where you need it. Okay, this slide makes a really critical point. var isn't just some static placeholder. It's an active function call that grabs a value when the page actually loads. This is how you create a single source of truth for your design tokens. Things like your main brand color or your standard spacing. As you can see in the code, you define brand primary just once, and var summons it everywhere. You change it in that one spot, and your entire theme updates instantly. Now that's efficiency.
We've looked at CSS variables before, but now we inspect and consider their true function. var is more than a lookup. It allows us to centralize every foundational decision: color, radius, spacing, motion, typography, scale, you name it. The real power here is consistency. One decision, one definition, infinite reuse. When our UI changes direction, and it will, this centralization is the difference between a 5-minute change and a 5-hour refactor.
So you've summoned your values. Awesome. But what about shaping them? Here's a super common problem. How do you make an element go full width, but still account for the padding on its parent? You can't just write 100%. You need to do some math.
And for that, we bring out the hammer of precision, calculate. This function is your forge hammer. It lets you do arithmetic right inside your CSS. It's how you strike those exact calculated blows.
This is where many developers finally understand CSS as a layout engine rather than merely a presentation layer. Calc lets us blend units that were previously impossible to reconcile, percentages with pixels, rems with viewport units. That unlocks precise alignment, container-aware spacing, and truly fluid boxes without relying on JavaScript or elaborate hacks. Most importantly, calc lets us build formulas that represent our design logic. Our CSS becomes a description of relationships, not a pile of fixed values.
The real power of calc is its amazing ability to mix units. Take a look at the code here. We're calculating a width using calc of 100% minus var-gap times 2. It's taking a flexible percentage and subtracting a fixed rem value that we just summoned with a variable. This kind of thing used to be a major headache, but calc makes it, well, trivial.
Consider mixing percentage with rem as acknowledging that not all sizing concerns originate from the same design aspects. Percentage responds to container size. Rem responds to document scale. Pixels respond to pixel precision. Blending units ensures your components stay balanced as both the environment and the user settings shift.
Let's move over to the Precision Anvil demo and see how this all comes together. Here, calc is doing all the heavy lifting. It's defining that inner width by subtracting fixed padding, and it's even positioning the hammer by mixing a percentage with a pixel offset. It's all about creating that perfect balance for a super polished UI. Okay, so we can summon values and we can shape them, but what happens when our fluid values get a little too fluid? We need to set some boundaries. We need guardrails.
For that, we have the twin blades of constraint, min and max. And the logic here is just beautifully simple. Min looks at all the values you give it and picks the absolute smallest one. Max picks the largest. They're basically the gatekeepers that keep your designs from going off the rails.
Min and max. These are two of the most underrated and frequently misunderstood functions in CSS. They let us declare absolute constraints without media queries. Min forces our element to respect a maximum, and max forces it to respect a minimum. Wait, I sense confusion. Min enforces a maximum, and max enforces a minimum? Let's hammer this out. When we declare width min 60%, 320 pixels, the browser is going to choose the smaller of the values we give it. This effectively creates a maximum allowed size, because no matter how big 60% gets, the element will never exceed 320 pixels. Min picks the smallest value and gives us a maximum. It caps growth. Now, max. With max 60%, 320 pixels. Choosing the largest value effectively becomes a minimum allowed size, because no matter how puny 60% becomes, the element will never shrink below 320 pixels. Thus, we prevent collapse. This is design intent expressed with mathematical clarity, even if it boggles our minds at times. We're no longer begging the browser not to let our layout break. We're giving it the exact rules that prevent such breakage.
And this demo shows their purpose perfectly. In the blade chamber, the blade of restraint uses min of 60%, 320px. It'll pick whichever of those values is smaller, which basically creates a ceiling it can't grow past. The blade of dominion uses max, creating a floor it can't shrink below. Put them together, and they prevent your layouts from ever breaking.
So we've set a floor and we've set a ceiling. But what if we could do that and define a perfect fluid value for everything in between all in one shot? It's time for the ultimate value spell. Meet the Trinity Rune Clamp. It takes 3 arguments, and the order is crucial. So remember this. First, the absolute minimum value. That's your floor.
Second, the preferred flexible value. This is often based on the viewport. And third, the absolute maximum. That's your ceiling. Floor, fluid metal, ceiling. Simple as that.
Yes, min and max are magnificent implements of constraint, but clamp is where everything comes together. A firm floor, a solid ceiling, and an intelligent value that flows between them. The magic isn't just responsiveness, it's predictable responsiveness. Our typography, our card widths, our white space, all of our component dimensions now scale smoothly while respecting boundaries we choose deliberately. In the darker times, we may have written 3 media queries just to keep one font size under control. Clamp banishes such tomfoolery to the dusty, distant, unnecessarily unmanageable past.
Now, the most popular use for clamp by far is fluid typography. I mean, look at this one line of code. Font size clamp of 1.15 rem, 1 rem plus 2 VW, 2 rem. Here, 1.15 rem is our floor. The text will never ever get smaller than that. 2 rem is our ceiling, and that middle part, 1 rem plus 2 VW, that's the magic. It scales perfectly with the viewport width. You get completely fluid text with 0 media queries. It's incredible. Just watch the Trinity sigil here. As the viewport changes, see how the orb scales so gracefully. There are no sudden jumps at breakpoints. It's perfectly fluid, yet it's perfectly contained. That's the elegant power of clamp.
Okay, we've mastered the individual runes. Now it's time to enter the alloy chamber, where we're going to learn how to combine these functions into some seriously powerful, intelligent alloys.
Now, with our tool chest fully equipped, we may enter the greatest mindset shift of them all. Masterful CSS is not about picking the right function, it's about composition. We can use var inside calc within the fluid yet constrained magic of clamp. With these nested and integrated functions, we create components that adapt to different screen sizes, respond to different themes, and respect different motion preferences, while remaining consistent in our design system. A modern component is not a handful of properties. It's a system of relationships, constraints, and intentions expressed through functions.
And this really brings us to the core philosophy of the Function Forge. Your HTML gives you the skeleton. Your design tokens, stored in variables, they define the intent. But it's these functions that actually forge the dynamic, living behavior of your components. And this is the alloy core, where we see all our tools working together. The overall size is controlled by clamp, which gives us that fluid but contained behavior we want. The border width uses max, so it has a solid floor and never disappears on tiny screens. And of course, you can see var is being used to pull in the core color and the spin rate. This is composition, layering functions to forge a single intelligent component. So let's do a super quick recap. Var remembers and summons our tokens, calc computes and shapes our values, min and max protect and constrain them, and clamp hybridizes them into a single awesome adaptive value. But your training isn't over. To keep your runes sharp, go visit the full lesson page for a written guide, fork the demo repo on CodePen to experiment for yourself, and make sure you explore all 3 parts of Professor Solo's WebDev TNT triad: the lesson, the demo, and, of course, this explainer. You now have the tools to forge CSS that doesn't just look good, it thinks. Go build something brilliant. And, as Professor Solo always says, P.S., function fantastically.
Today, we learned to compose value systems that respond, think, and self-regulate. Yet still, returning intelligent values sets only one chapter of our CSS mastery adventure in place. Next, we'll step into the realm where those values meet structure, where lines become columns, columns become regions, and regions become purposeful compositions. Function Forge informs us to craft the metal. The architect teaches us to construct the world it lives in. grid, flow, hierarchy, and balance. Not just what goes where, but why it works. Prepare yourself, apprentices. The architect arrives soon. P.S. We've forged our values. A structured skyline awaits.